Hello, future educators, and welcome to your Friday lesson. We're going to be covering a fair amount of ground today, so fasten your seatbelts. We're going to start with negation. So what we want to do is just take a quick peek at how we negate compound statements and how we negate conditional statements. Then at the end of the lesson, we're going to take a look at how to create some new conditional statements from old conditional statements. Along the way, please make sure if you have any questions just to maybe jot them down in the margins of any notes that you're taking. And that way when we get together next week, if you do have any questions about this portion of the lecture, it's very easy to find those questions and I'll be able to help answer some of those questions. We are going to see more examples of this next week as well when we start to do our our logic chapter summary on Monday too. So what I've done here for compound statements is I've pulled up the two truth tables that we've been working on. The one on the left here is for our AND connector, and the one on the right is for our OR connector. And one of the patterns that I want you to notice is the number of trues and the number of falses in each of the columns for our connectors. Notice that our AND connector is only true in one instance, and it's false in all of the other instances. However, our OR connector is only false in one instance, and it's true in all the other three instances. And this really isn't a coincidence when it comes to logic. These compound statements, especially their negations, are somehow connected to each other. And our goal is to try to figure out how to match these up one by one. And usually kind of the first place that we want to take a little peek at is these two here. So for instance, in row 1 of the AND connector's truth table, and in this final row of the OR connector's truth table, these are kind of the odd ones out, right? This is the only time the AND connector is true, and the only time the OR connector is false. And this essentially gives us kind of a way of mapping back and forth between these things using the logical negation. So the idea here is if I have a truthful statement with an AND connector, the only way that I can make it false is to use the OR connector and to negate the two initial statements. So I'll say that one more time, maybe with some highlights so you can kind of see what I mean. If I start out with a truthful AND connector statement, the only way to make it false would be to change to the OR connector, right? So I'm making a false statement, and then I take these two initial statements that were both true, and I negate them, and I make them both false. So this is the logical negation of an AND connector. We change the connector type, and then we negate both of those statements. And I think kind of the concept is potentially best illustrated through an example here. So let's say we have the following set of three objects. We have a triangle, an octagon, and a square inside of our set of shapes. And the statement that somebody says to you is a square is in the set and a triangle is in the set. And I mean, obviously right now they're telling us a truthful statement. Both a square and a triangle can be found inside of the set. So in other words, I'm in row number 1 of my AND truth table. I have a truthful first statement, a truthful second statement, and the overall compound statement is going to be true as well. If I want to negate this statement and make it a false statement, I might say something like this. Neither a square nor a triangle is in the set. So I've changed that original statement that we had into a false statement, right? Obviously both of these shapes are inside the set, so this new statement that I've created, neither a square nor a triangle is in the set, this is a false statement. And in fact, it's exactly what I would get by kind of connecting these two connectors together, right? So I've now created an or kind of compound statement where the first statement is false, the second statement is also false, and overall our truth value is false as well. Let's see, what else can I do here? So notice that I really can't. So the idea is to try to kind of keep the subjects the same, right? We want to get the opposites of our subjects when we're negating, right? We need to get our nots in here. So I can't keep a square is in the set and a triangle is not in the set. Like I can't negate one without negating the other. So that's kind of the issue here when we work on negation, is we need to figure out how to get the not in here. And the easiest way to get the not in there is to distribute it to both of our simple statements. And then the only way to kind of make sure that the truth value works is to change the connector. So let's work on another example where hopefully will start to kind of come a little bit clear. The next example here is the sky is green or the grass is red. So obviously both of our simple statements here are completely false. You know, in my world the sky is not green, and in my world the grass is certainly not red. So if somebody came up to me and said the sky is green or the grass is red, I'm going to be like, well, no, the sky is not green and the grass is not red. What the heck are you talking about? Would probably be my response, right? So I might respond with something like this. Just let me get black. So that would be my kind of counter argument. They're saying something using this OR connector, and I think both of their statements are false. So I'm going to rebuttal them by negating both of their statements, right? I want to keep the subject the same. I want to keep the idea that we're talking about a green sky and red grass the same. So I negate those statements, keeping the subjects the same, and I'm changing my connector, right? So the sky is not green and the grass is not red. What the heck are you talking about? And so this is kind of the key idea when negating our compound statements. The key idea is to look at both of your simple statements. You're going to negate both of those simple statements to ensure that your subjects stay the same, that you're talking about the same thing, just the opposite of what the statement says. And then what we do to change or alter the truth value is to actually change the connector that we're using. So an or would change to an and, or an and would change to an or. So that's your kind of two-step process for finding the logical negation of a compound statement. All right, so try to leave a little brief pause there in case you needed to pause and kind of copy some stuff down and kind of get caught up and start thinking about what I said there. And like I said, if you have questions, try to jot them down inside your notes, and then we can come back and hopefully try to answer some of those questions next week. The next thing we want to look at doing is negating a conditional statement. And surprisingly, conditional statements are a little bit easier to negate than a compound statement, even though they contain two different substatements as well. So here's the truth value of a conditional statement. So remember that really the only time a conditional statement is going to be false is if the hypothesis is true and the conclusion is false. And it's really this row here that tells us how to negate a conditional statement. A conditional statement is false if the hypothesis is true and the conclusion is false. So the easiest way to negate a conditional statement is to create a compound statement where the hypothesis is true, where statement A is true and statement B is false. So our first simple statement is true and our second simple statement is false. So for example, if we take that statement we were looking at this week, if I am drinking wine, then I am happy, this conditional statement makes some kind of remark about what's going to happen if I am drinking wine. So it says, if I'm drinking wine, then I'm going to be happy. But if someone walked up to me and said this, if I'm drinking wine, then I'm happy, the only way for me to kind of logically argue with them would be to say, okay, I need to make sure that they're drinking wine, and I need to make sure that they're not happy. So this is the logical negation of this particular sentence. So let me get it in black here. Okay, so in other words, we make sure that the hypothesis happens. So we assume that A is true. We connect our statement B with the word and we make sure that statement B gets negated. So, and I am not happy. This is what we call the logical negation of a conditional statement. We make sure that statement A happens and statement B doesn't happen. Okay, so I've just summarized that here inside of the key idea for you. So the idea is we kind of get rid of the if and the then. We put the word and in between our simple statements, and then we make sure to negate the concluding statement because that original statement says, if this thing happens, then this thing should happen. So the only way to rebuttal somebody is to say, make sure the first thing happens and the second thing doesn't happen. Okay, so once again, just tried to put a little bit of a pause in there so you could kind of copy some stuff down and get caught up. And the last little bit of the lesson today just deals with how to create some new conditional statements from an original conditional statement. So if we're given a conditional statement, there's two things that we could do to create new conditional statements. One of those ways, or one of those things that we could do, is to actually swap the order of our substatements. So we could actually switch the order of A and B, and that potentially could create a new conditional statement for us. Okay, so instead of saying if A then B, maybe we want to say something like if B then A. Maybe that makes more sense. So that's one way we could create a new conditional statement. And the other way we could do this is to look at the opposite of A and B. So in other words, we could think about negating A and B as well. So those are our two options when creating some new conditional statements. And it turns out that one or both of these things that we could do have special names. So let's take a look at an example and how to create some of these new conditional statements by doing one or both of these operations. So our original statement is of the structure if A, then B. And maybe I'll just kind of highlight A and B here again. So if it rained, then I used an umbrella. So we have the hypothesis is that it rained, and the logical conclusion is that we're going to use an umbrella. So this is our original conditional statement. I don't know if it's true or false because I don't know if it's rained or it hasn't rained. So the truth value of this original statement for the time being isn't important. What's important is how we can swap around or adjust statements A and statement B to create some new conditional statements. No. Okay, so let's work with, let's say, the inverse and converse first. So let me just double check and make sure that I'm not going crazy. So yes, so converse. So inverse is what happens if we negate both of our statements. So if I take my original statement and I change it to something like, if it didn't rain, then I didn't use an umbrella. So this would be an example of the inverse statement to our original. So if it didn't rain, right? So notice I'm getting my not in here. Then I didn't use an umbrella. Okay, so I'm keeping the order the same. Rain comes first, umbrella comes second. I'm just negating those simple statements. So this is what we call the inverse of the original statement. Next up, let's talk about the converse. The converse is what happens if I switch the order of A and B. And yes, it's converse like the sneakers. Okay, so I'm not going to negate anything. I'm just going to swap the order of the hypothesis and conclusion, and this is going to create a brand new conditional statement that still has very similar subjects to what we were talking about. So the converse statement would look something like this. If I used an umbrella, then it rained. Okay, so taking A and B and just switching the order. And then finally, if we do both the swap and the negation at the same time, we get a statement known as the contrapositive. And the contrapositive has the following structure. If not B, then not A. So notice that not only am I negating A and B, but I'm also switching the order of A and B as well. So it's kind of like the inverse and the converse put together. And the contrapositive for our particular statement would look something like this. If I did not use an umbrella, so if I didn't use an umbrella, then it didn't rain. So there's our contrapositive statement. So swapping the order as well as negating those substatements. Now it turns out that I've kind of paired things up very nicely on the screen just to kind of speed us through the lesson a little bit here. It turns out that the original statement and the contrapositive actually are logically equivalent. However, the inverse and the converse are not logically equivalent to the original statement. So in other words, the original statement says what would happen if it rained. So if it rained, we know we're going to use an umbrella. It doesn't really tell us what happens if it doesn't rain. So the inverse is not super helpful here, right? So the inverse, says if it didn't rain, then I didn't use an umbrella. But I mean, maybe I used an umbrella because it was sunny out or something. So the inverse doesn't necessarily have the same truth value as the original statement. In fact, most of the time it doesn't. And that's the same with the converse. So if I used an umbrella, well, actually, sorry, I think I argued the other way, didn't I? If I use an umbrella, then it rained. Well, I could use an umbrella, if it's sunny outside, for example. So that's the argument that the converse isn't the same as the original, because I could use an umbrella even though it's not raining. If it didn't rain, so the argument for the inverse is the original tells us what to do if it rained. It doesn't tell us what to do if it didn't rain. Let's take a quick peek at the contrapositive. So the contrapositive says if I didn't use an umbrella, then it didn't rain. So the original says if it rains, we're going to use an umbrella. So let's say we don't use an umbrella. I think that's logically equivalent to the original, right? If we don't use an umbrella, we can, I think, logically conclude that it didn't rain. Because if it rained, we definitely would have used an umbrella. So if it didn't rain, or sorry, if we didn't use an umbrella, it must be that it hasn't rained. So yeah, so that's like the interesting part, I think, about how all of these new statements kind of line up. These two tend to have the same truth, just stated in slightly different ways. And surprisingly, the inverse and the converse have the same truth as well. And I'll let you ponder a little bit more about why that is the case, and maybe you can try to convince yourself that those two are always going to have the same truth value. Yeah, it actually turns out that the inverse and converse happen to be contrapositives of each other. But here's kind of the key takeaways that I want you to know for creating these new statements. The big one is number one, and this is definitely big if any of you are thinking about going into any careers into mathematics. As mathematicians want to prove things, sometimes it's easier to work with a contrapositive statement than it is to work with the original statement. So we maybe talked briefly about how a conditional statement like this needs to be proved. I assume that the hypothesis is true, and then I try to figure out if the conclusion is also true. But sometimes it's easier to rewrite it and think about whether or not the conclusion is not true, and then show that the hypothesis happens to not be true. So, not really something major that you need to know if you're going to be going on into elementary teaching, but, if you're going to teach, some high school proofs, or you want to take some more mathematics course, this connection between the original conditional statement and the contrapositive is one that's actually quite important for mathematical proofs. So that's kind of my brief little synopsis of the last little bits that we're going to be chatting about with logic. So on Monday, just be ready for some more examples. I'll try to have a bunch of examples kind of lined up, and a bunch of examples that maybe are not necessarily in sequential order. So we get a lot of nice mixed practice. Someone please remind me, I do want to go over that counterexamples worksheet as well. So we can maybe try to do that at the beginning of class on Monday too. So if you haven't done that, do that before Monday, and Monday will be kind of a big kind of summary day. Maybe look nice, maybe, like put on a nice shirt or something. Maybe we'll do some breakout groups on Monday so you can discuss some questions. Not like super intense, but maybe a couple times just so you can talk with somebody that's not me, because that's fun. So that is everything I would like to cover for today. So have a lovely weekend, everybody, and I will see you next week.